Hi, I'm Alex O'Neill. I'm a computer science freshman here at Carnegie Mellon, and this is my 15-112 term project, TerraMotus. TerraMotus aims to bring a unique user input into the realm of computer simulation. It uses a Sandbox and a Kinect to scan an arbitrary terrain generated by the user, and it puts that into a physics engine where it gives the user a buggy to explore and interact with their terrain. So, let's get to it. So here's the Sandbox. This is the way that the program gets the user input. This input method was inspired by a project called Augmented Reality Sandbox. It is a project designed to be given to science centers for a Kinect to scan a very similar sandbox, but project a topological region onto the sandbox for kids to play around with and view and kind of have fun with. So this input method really inspires creativity within the user because just as kids, they get to play in the sand and they get to make whatever shapes they want. And that's the other beauty of the sand. You can make whatever you want. I mean, within the limitations of the sand, you can make valleys, you can make rivers, you can make whatever you want, and it gets scanned right into the program. So let's go check it out.
Okay, and here we are. So once we run the program, we're given a menu. We have the About menu, which tells us essentially about the game and how to control the car within it. If we go back home, we're now given both a Browse menu and a Play menu. I'll get back to the Browse menu. So if you have a Kinect connected, the Play menu will let you use the Kinect as an input option for the program. Otherwise, it'll let you use CSV files to run the simulation. So right now we have a previous Kinect scan in there, but right now I want to play with a different Kinect scan. So let's get a fresh one. What's happening in the background here on a different core actually on the computer is that we're taking the data from the sandbox. You can remember it from the earlier part of the video. And we are converting it to the different arrays that are needed for both OpenGL, which is the graphics engine, and ODE with physics engine. They both require a distinct data type for simulation, and that's what we're preparing right now. Also in the background, before it's actually pushed to those different arrays, are filters applied to this data. So the Kinect gives back data which is actually fairly error-free, but there are still some errors, usually on the fringes of the Kinect data, and also kind of spread throughout. So what the filter does is it takes those errors and it removes them and replaces them with values which it thinks are similar to values around it. And it's actually surprisingly robust for what it can do, and it can essentially guess what should be around it, and it is often very correct. So here we are in simulation. As you can see, we're given a very simple car to kind of drive around. These are the finger drag I did earlier, so we can explore the simulation. We can play around with what we're given. So yeah, so let's say we don't like this simulation. Let's say we want a different one. So either we can go back home and we can scan the Kinect data again, assuming we changed it, or we can read from a CSV file. So I could go and check out one of the previous CSV files, or if we change our mind, we can actually just go back directly into simulation where we last were without losing any of our progress wherever we end up. So let's say none of those tickle our fancy. So we can actually go back home and we can browse for tracks that are actually saved online. If we go to the website for this project, TerraMotus, it's on my domain. We have different maps that other users have uploaded. In my case, it's only me, but the idea is that users can upload their maps to this server, and you can then download these maps directly from the game. There's also download buttons here which will save them right to your downloads folder, and you can do what you please with them. But the idea is that really you take these and you download them within game. So let's say I want to play with a giant spoon I scanned. So let's go do that. So here I'm going to click on sample spoon. Right now in the background it's both downloading the file from the server, it's saving it into your maps directory so you can play it again without having to download it, and then it's also converting that CSV file then into the different arrays that are required for the program. What's special about this is now it doesn't have to filter the Kinect data, because when the Kinect data is saved as a CSV file, it's already filtered. So we don't have to waste any of our processing time actually doing that. the part in the background is actually built on an object-oriented platform so that you can actually add different data sources just straight into a class called a converter, which takes that data source and converts it into the required data form. So this has support for specifically extendability both within the data sources but almost everywhere else in the program. So this car, you can write different cars which extend it. You can add like a spoiler, for instance. So this feature is definitely something that I wanted to keep throughout the program. So anyways, here we are with the Big Spoon. As you can see, it was just downloaded from online. So of course we can download programs, but I want to actually share my program or my really cool track that I just made with the world. So we can go home, we can load up one of the files. The most recent file would be the higher number. So this is just reading in the CSV file we saved earlier from the Kinect scan data. Just give it a moment. So here we are back in simulation. Again, this just resets us wherever the reset point in the simulation is. That's usually in the center of the map. Again, we can keep exploring. And if we want to, we can also pause the simulation. But I don't have to usually pause simulation. So anyways, here we are. So let's say I think that this map is really just amazing. I love this map so much. I think everyone would have so much fun with these different ruts I made with my fingers. So we're going to share it. So all we have to do right here is just click this button, the upload button, and you can keep playing in simulation, doing whatever you want. And in the background, it actually uploaded the file. So let's just pause this. Let's go back onto the website. So here are the previous files, and if we refresh the page, now look, we have our file. Those are the ruts that we were playing in. Also looks like a bird. Anyways, so yeah, the idea is that you can share your map pretty easily with anybody else who wants to try just by uploading it to the website here. So here we are, back in simulation. Let's keep playing a bit. Perfect.
And that's my term project. I'd like to thank Professor Cosby for teaching such a fantastic course in Python. I'd like to thank my CA Lena for helping me get this far. And I'd like to thank 3 different projects for helping inspire TerraMotus. The first project is the Augmented Reality Sandbox, which gives science museums the tools with the Sandbox and a Kinect to teach kids topology. The second project is the Kinect Fusion by Microsoft, which brings scanned Kinect data into a computer graphics engine and vice versa. And finally, I'd like to thank Intel's Perceptual computing project for bringing direct Kinect input into a physics engine. All of my code can be found on my GitHub page, linked below, as well as my website, which is also linked below. On my website, you can also find my contact information and anything else about me that you might want to know. Thank you for watching.